Hello students, and today we are going to do the IIT JEE ZEOT paper. So today's topic will be our work, power, energy and rotational dynamics. So we'll do one by one. Please go through that. Okay, come on. First question: a block of mass m. A block of mass m is kept on a platform which starts from rest. So m is the mass of the block and it starts from rest. So initial velocity is 0 with the constant acceleration g by 2 moving upwards. So we are having a body of mass m. It is kept on the platform and the platform is moving up with an acceleration due to gravity g by 2. So something connected with the motion of the body in initial frame of reference. So we want to know what is the work done by the normal force after an interval of time. So we have to find out the work. So we know that work done by normal force. Work done by normal force. So we know that work is equal to force into displacement. And what type of force is a work done by normal force? So first we have to measure the normal force. After that only we have to measure the work done. Okay. So first we'll draw the free body diagram. Yeah. So let us assume that this is the platform. A body of mass m is placed on the platform and it is moving up with an acceleration a equal to g by 2. Now what we have to find out is, we have to find out the normal reaction. Okay, so now draw the free body diagram. So the body will have its own weight and this is action. For that action will have reaction. That reaction is nothing but normal reaction. So I am using the letter n. So now we have to find out n. For that what you have to do? We have to write the equation of motion. So that will be n because upward motion. So upward force is more than the downward force. N minus downward force. This is called net force. We know net is equal to m into a. So m into a. So the a will be nothing but g by 2. They gave. So now find out m. Therefore n is equal to mg plus mg by 2. That all come out as 3mg by 2. So like that, first we have to find out the normal force. So if you want, you can note down this is the normal force. But they are asking the work done by the normal force after an interval of time t. We got the value of force, but work is nothing but force into displacement. So now we have to find out what the displacement of the body in the upward direction in an interval of time t. For that what you have to do? So now we are going to find out the distance. So let us assume that the body is traveling a distance of s in an interval of time t and it is moving with an acceleration of g by 2 from rest. From rest, like that. So I know u, I know a, I know t. Can't you find out the value of displacement? Definitely. S is equal to ut plus of a t square. That's the concept. But the body starts from rest. So initial velocity is 0. So the distance will be half into a. Again a is given. G by 2 into t square. So when you do the simplification, it is g by 4 into t square. So like that we got the displacement. Okay. Yeah. So in the first paragraph, we found out the force. In the second paragraph, we calculated the distance. So now it is the time for us to find out the work. Therefore, work is equal to normal force into distance. It is a normal force. If you can't understand, you can say Fs also. Okay. Just for understanding, I put n. Normal force into distance. Both are in the same direction. Theta is equal to 0. So the normal force will be 3 into mg by 2 into distance we have calculated G by 4 into T square. That's all. We got it. Now do the final calculation. We are having 3 and we are having 2 into 4, 8. Of course, we are having M and we are having 2 G's, G into G, G square, and we are having T square. So the answer will be, the work done by the answer will be 3 by 8 M G square T square. Now see the choice. Yeah, got it. 3 by 8 M G square T square. So the fourth option will be the correct answer. In this way we are supposed to do the question. It's a very simple question. Now let us go to the next one. Yeah. So we will read the question. The potential energy. We know that potential energy is a function of distance. It may be x or it may be r. In this case, they gave the value of r. So we will note down the potential energy. The letter used for potential energy is U. A is a constant and it is varying with r raised to 10 minus b by r raised to 5. They gave. So this is the variation of potential with respect to distance that they gave. Of course, A and B and all constants. Okay. So come on. The equilibrium distance between the two atoms will be. That means two atoms are at equilibrium. Two atoms together, they are at rest. So then the net force acting on the system will be 0. So they said equilibrium. That means from this word, we will get that the net force must be equal to 0. So the question is, I want to find out the distance between the two atoms so that the system is at equilibrium. So net force will be 0. Okay. So first we have to find out the force and then we'll equate it to 0. Then we'll have idea about the distance. Okay. So now we'll start thinking. So they have given U, but I want F. So is there any relation between force and energy? Yes. We all know that F is equal to minus du by, you can put dx or you can put dr. So now I'll put dr because u is a function of r. Okay. So what the meaning of this equation? If you differentiate potential energy with respect to distance, we'll get force. After that, we'll equate force to 0 because system is at equilibrium. Then we'll get the value of the distance between the atoms. Okay. So now I am going to differentiate. So F is equal to, so we'll differentiate this equation. So I put minus. How to do the differentiation? So you are all math students. You can say that. So somewhere I will do, where I have to do. So I will do that r raised to 10. Take 10 to the numerator. So it will be r raised to minus 10 followed by a. It is in the form of x raised to n. N into x raised to n minus 1. So when you do this differentiation, you will get minus 10a into r raised to minus 11. But now I will take 11 to the denominator. Minus 10a by r raised to 11. So that quantity I will write it here. Minus 10a by r raised to 11. Like that I had to do another quantity. That is what already ordered minus 1. So now in the similar manner, I had to differentiate b by r raised to 5. So for the differentiation, let me take that denominator to the numerator. But now again in the similar manner, I am going to differentiate. Again it is in the form of x raised to n. So it is minus 5b into r raised to minus 6. That r raised to minus 6, I will take it to the denominator. So it will come out as minus 5b r raised to 6. So when you put that value here, minus minus becomes plus 5b by r raised to 6. So this is the expression for force. But the system should be at equilibrium. So I will equate it to 0 because the system is at equilibrium. Okay. Yeah. So now I want to find out the value of r. Minus is not an issue. So take the start to that side. So we'll do. So it will be 10. E minus angote ponundu plus 10a by r raised to 11 is equal to 5b by r raised to 6. Now you can solve. 5 10 goes by 2 times by 5, and this is 6, and this is only 5. Okay, so now we are getting the equation as 2a by r raised to 5 is equal to b. Nothing is there. So therefore r raised to 5 is equal to 2a by b. Obviously we want r. So the r will be equal to fifth root. Fifth root of 2a by b. So the answer is 2a by b raised to 1 by 5. Yeah, correct. You can take the choice 3. In this way we are supposed to do. Okay. So let me move on to the next question. Yeah. Again read the question. A particle of mass m. Okay. A particle of mass m moving in a circle of a fixed radius. Okay. In such a way that its centripetal acceleration. So centripetal acceleration. What is the letter we use for centripetal acceleration? AC. Please write AC. What is AC? AC is given as n square r t square. So AC is a function of time. So it is not constant, it is a variable. Please observe that. So I want to know what the power delivered by the particle by the force. So now what you have to do? We have to discuss where it will have power. Power comes from work. If the work, if any type of force does work, then it will have power. Okay. Then what type of force I have to take? Because we may have two types of accelerations. So we may have two types of forces. Which force is giving power? Which force is doing work? Due to that, what the power? Like that we have to think. Okay. So if you ask me to explain, so in our circular motion, so this is AC, therefore this will be FC, and of course we'll have velocity. The velocity direction can be taken as displacement. So work done by FC will be mostly 0, because FC and V or FC and D are perpendicular. Theta will be 90, work will be 0. So there is no power because of FC. So there is no power because of centripetal force. Then what had to do? But in addition to AC, we'll have AT. What is AT? Stands for tangential acceleration. Then what the direction of that force? That force I will write it as FT. So now FT and V. FT and V are in the same direction. FT and D are in the same direction. Theta is equal to 0. Work is there. So power is there. So to find out this power, you have to take work done by FT only. You should not take work done by FC, because there is no work done by FC, where C is the centripetal force. But we'll have work because of tangential force. So we have to concentrate on tangential force, like that. So understood? So for that I am doing the work. Okay. So what is power? Force into velocity. First we have to find out velocity. After that we have to see the tangential force. Okay. But this is not tangential force. This is not tangential acceleration. This is centripetal acceleration. So from centripetal acceleration, we have to find out the velocity. That velocity we have to differentiate. Then we will get tangential acceleration. Then we have to find out tangential force. Then we have to find out the power due to the tangential force. Okay, you just follow me. So this is AC. What is AC? What this AC will go? AC is nothing but V square by R. Of course, capital R. V square by capital R. That is equal to N square R T square. So when you do that work, V square is equal to N square R square T square. That means V is equal to N R T. So this is the velocity of the particle moving along the circumference of the circle. But we have understood that it is also a function of time. So it is variable. It's not a constant. The magnitude of velocity is changing. So definitely we'll have another type of acceleration called AT. So now we want that AT. AT, be careful, AT, velocity kitty, പക്ഷെ നമുക്ക് AT വേണം. Because of AT only we'll have FT. So what is AT? AT is nothing but it is the acceleration because of change in velocity. So I have to take dv by dt. So I have to do the differentiation of this. So when I do the differentiation, t will be 1. So nr I will get. So I got the AT formula. I got the value of AT, that is tangential acceleration. Now what I have to do? So I told now already we'll have power due to the tangential force. Okay, so now power is equal to force into velocity. But here the force are tangential force, like that. But we know that force is nothing but mass into acceleration. But what type of acceleration? Tangential acceleration into the magnitude portion of velocity. Very carefully we have to do. So that is equal to m into AT. But by that time AT is ready. What is AT? nr into V. By the time V is also ready. What is V? nRT. Like that. Now we multiply here. M is there, n square is there, r into r square is there, t. So the power is equal to m n square r square t. M, yeah, of course I use small letter, it doesn't matter. M n square r square t. Like that you have to do. Okay, so we have to find the power due to Ft. It is not power due to Fc. Okay, power due to Fc illa, power due to Ft unde. So we have to find out At and we have to multiply it with V, then only we will get it. Go through that, please. And the next question will be, yes, I think it is the question from collisions. Read it. A body of mass makes an elastic collision. If it is an elastic collision, it is very easy because we are having standard equations. Okay, so it is an elastic collision. Please note down, it is an elastic collision and we are having a body of mass m1. m1 is equal to 2 kgs. It is going to collide with the stationary ball at rest. So second is at rest, u2 is equal to 0. But I don't know the mass of the second body. Mass of the second body we have to find out. Okay, and the first body and continues to move in the original direction but with 1/4 of the original velocity. So the first body, this is the first body, m1 is the first body. Let us assume that it is moving with u1 and it is going to collide with m2, which is at rest. Now the first body is colliding with the second body. After collision, first body is continuing with the 1/3 of the initial velocity. So this is m1 and we'll say v1. V1 and u1 by 3. 1/3 they said, na? 1/3 like that. But we don't have any idea about m2. We don't have any idea about m2. That is not required to do this question. I don't have any idea about m2, so that is not required. Just leave it. Okay. But now we have to connect all the three. Okay. So I want m2. So there is a standard formula for elastic. Come on, say v1 is equal to m1 minus m2 into u1 by m1 plus m2. Even if you take the other term, that will become 0 because our u2 is 0. Second body is at rest. So this will become 0. So you can take only the first term. Okay. Now substitute the values. That's all. What is v1? u1 by 3. And what is m1? 2 kgs. m2 നമുക്ക് കണ്ടുപിടിക്കുക by again 2 plus m2 into u1. u1 is u1 only. That's all. Come on. So u1 gets cancelled. Cross. Do the cross. 2 plus m2 is equal to 3 into 2 6 minus 3 m2. So bring m2 this side. m2 plus 3 will be 4 and two plus m2 4. This will be equal to how much? 4. I am getting 1/4. Sorry, this is 1/4. See, I made the mistake. It is not 1/3. It is 1/4. So So generally it is 1/4. So it is 1/4. So 2 plus m2 will be equal to 4 into 2, 8 minus 4 m2. Take m2 to this side. 5 m2 will be 6. So m2 will be 6 by 5. So it will be 1.2 kgs. So 1.2 kgs. So this is very simple question. If you remember the formula, you can do it. Okay. We'll go to the next question. And this is also based on collision only, but we have to do collision in 2 dimension because they gave it in vector form. Okay. So if you want collision in 2 dimension, I'll go for the coordinate axis. Come on, read. A particle of mass m in shell moving with in shell. So this is the particle of mass m and it is moving with the velocity u I cap. They said u I cap, that means it is moving along x axis. Perfectly inelastic. Perfectly inelastic. Sorry, not perfectly elastic. It's not elastic. Perfectly elastic. Elastic. Again they said elastic. That is, we can apply law of conservation of momentum. We can apply law of conservation of energy also. Okay, because it is collision in 2 dimension, we can't depend on the formula. We have to depend only on the concept. With a 3m mass which is at rest. So second body of mass m, it is at rest. So this is the figure before the collision. Okay. Yeah. It moves with the velocity Vj bar. Which one? First body is moving with velocity Vj bar. Vj bar means it is moving along y-axis Vj bar. So mass is m. Then what is V? V for what? What is V? Then V is given by. Yeah, so then what is V? Yeah, okay. So then what is V? It is moving with Vj bar. What is V? Yeah. We want this V only. What is V? But we don't know what the velocity with which the second body moves. Okay, so let us assume that second body moves in this way. Second body mass is 3m. Let us assume that it is moving in V2 like that. And we want angle also like that. Okay. So here direction is okay, here also direction is okay, but here direction is not okay. Okay. So now what you have to do, we will go for components. You can go for velocity components or you can go for momentum components. So I will take velocity components. So here it will be V2 cos theta. If you want, you can put I cap. And here it will be V2 sin theta. But if you want, you have to put minus j cap like that. So now how to find out V? But by the time V2 will be introduced. So what you have to do in this type of questions? Apply law of conservation of momentum along x-axis. Again do for along y-axis. After that you can apply law of conservation of kinetic energy also. Apply law of conservation of kinetic energy also. Come on, start applying law of conservation of momentum along x-axis. That is, we have to consider the momentum along x-axis. Is it moving along x-axis? Yes. So mu. I cap vanda. Okay. Is it moving? No, it is not moving. It is at rest. 0. Is it moving? Some portion. Next is it moving along x-axis after the collision? No. Is it moving along x-axis? Yes. Some portion is moving. Appa even is 0. For the first body after the collision, velocity along x-axis 0 because it is moving along y-axis. So for this, so it's 0 it plus 3m into, and some portion is moving along x-axis V2 cos theta. Like that we got the first equation. In similar manner we will go for y-axis. Is it moving along y-axis? No. Is it moving before? No. Is it moving after? Yes. mv. Is it moving after? Yes. Some portion is moving but in the opposite direction. So minus 3m into V2 sin theta. Call that as second equation. Or now itself you can simplify also. Okay. So the first equation will be m and m gets cancelled. So u is equal to 3v2 cos theta. That's the simplification of the first equation. Again this m gets cancelled. So I will take anyone here. So V is equal to, this is V2, 3V2 sine theta. That is the equation which we got it from second. And now what we had to do? We had to eliminate V2 because V2 they have not given. And we had to eliminate theta also. For that we will do squaring and adding. That I will do afterwards. Okay. And next what I am going to do? I am going to apply law of conservation of kinetic energy. When you apply law of conservation of kinetic energy, there is no need of taking the components. Directly you can apply law of, half mv square. So come on, start applying half into m into velocity u square. The other one is not moving. And again this is moving, half into m into v square. No direction is required. And again this big one, 3m is also moving, half into 3m into v2 square. Now no need to take components because it is energy. So again simplify, half gets cancelled, m also will get cancelled. So u square is equal to v square plus here 3v2 square we are having. So call that as third equation. Okay. So now what I am going to do is, I want v in terms of u. So I had to eliminate cos theta and I had to take the value of v2. That v2 I had to put it here. Then only theta and v2 will be eliminated. So here let me eliminate theta. For that I will do squaring and adding. Squaring and adding. Appa cos theta po. Squaring and adding. Do it. U square plus v square. Here 9v2 square cos square theta, 9v2 square sin square theta, 9v2 square into cos square theta plus sin square theta. Cos square theta plus sin square theta is 1. So we'll have 9v2 square. Call that as fourth equation. But now what you have to do? Take any one and substitute. You can do it anyway. Okay. So you can take v2 and you can put it anywhere. Okay. Yes or no? Yeah. But we have to do very carefully. So I am doing that. Or you can divide also. You can divide also. Divide is better. So for that what I will do? 1 minute. So u square minus v square is equal to 3v2 square. Third equation. So now I will divide. That's better. So divide 4th by 3. Or you can substitute also. Okay. U square plus v square by u square minus v square. This side 9v2 square. This side 3v square. So v2 square gets cancelled. 9 by 3, 3. Now do the cross multiplication. U square plus v square will be equal to 3u square minus 3v square. Now start doing the grouping. Bring it to this side. 4v square will be equal to 2u square. So v square is equal to u square by 2. So v will be equal to, take the root, u by root 2. So the value of v will be u by 2. So in this process, we introduce v2, we introduce theta, but everything is eliminated. Okay. So the answer is u by 2, u by root 2. Correct. So it is a elastic collision. So we apply law of conservation of momentum in two directions and we apply kinetic energy. We will get a single equation. That's all. So in this way you are supposed to do the question. Please note down. So let us move to the next question. Yeah. Again this is also based on collision and this is also almost like our collision in 2 dimensions. When you have angles, we have to understand that it is a collision in 2 dimensions. Again let us draw the figure and let us note down the data in the form of a figure. Okay, a ball with a speed 9 collides with another identical ball. Okay, so we are having 2 balls. M is at identical M, but this is at rest. U2 is 0 and the other one of course it is moving with U1 of 9 meter per second. After the collision, the direction of each makes an angle 30 with the, so they are moving in different directions. Yeah, so this will be the figure after the collision. So I will take this as the first body, I will take this as the second body. Masses are one the same, but I don't have any idea about the velocities. I will take it as V1, I will take it as V2, but they said they are moving with the same angles, 30, 30. This is the situation. If this is the situation, tell me the ratio of the velocity of the two balls after collision. That is x, and that is we want to know what is V1, V2, because we are taken that as V1, V2. They are considering that as x. Appo V1 by V2 are vendadu. Engane cheyyam? But you will have doubt, ma'am. Nothing is said about what type of collision it is. Don't worry, we will start applying law of conservation of momentum, because the law of conservation of momentum is applicable for any type of collision. Okay, so for any, it may be any type of collision, we will apply law of conservation of momentum. Engane apply cheyanam? Like previous one only. First we will go for components. So here we are having mv1 cos 30. Here we are having mv1 sin 30. And again for the second one, mv2 cos 30 ingoti, and here we'll have mv2 sin 30. So we want v1, v2 now. You can apply law of conservation along y-axis. Y is enough. Y. Apply law of conservation of momentum along y-axis. No, if I do x-axis, no, for y-axis immediately we'll get it. For y-axis immediately we'll get it. So I am doing with y-axis. X vanda, y component illa, y component illa, y component undu, mv1 sin 30, and y component undu, minus mv2 sin 30. This is after. So what will be the value before? 0 plus 0. Because this was moving along horizontal, vertically it doesn't have 0. This is at rest, so 0, like that. So she has applied the momentum directly for y-axis. So now m and m gets cancelled. It's a common, this also will get cancelled. So directly we will get the formula. So V1 minus V2 is equal to 0. Therefore V1, V2 are equal. Therefore their ratio will be 1:1. So directly you are getting. Okay. So if you do horizontal, what happens? No, we cannot solve. But this is the easy equation, like that. That we won't use it. Immediately we have to do both. So second one will go the answer, like that. Second one means applying law of conservation momentum along which will go the answer, like that. Now see this question. It is based on center of mass. 4 particles A, B, C, D, M, 2M, 3M, 4M are at the corners of the square. They have their own acceleration. They gave the magnitude, direction also they have given. So we have to take the direction into account. I want to know what is the acceleration of the center of mass. Generally, we might have studied position of the center of mass, velocity of the center of mass. Like that, we have to do the acceleration of the center of mass. So we know that acceleration of the center of mass will be, of course, sigma apply here, m1a1 plus m2a2, m3a3, m3a3 plus m4a4, because we are having 4 whole divided by sigma m. So this is a concept in this question. But how to apply? Okay. So for that, draw the figure once again. That figure is too small, like this, and the order is very important. Here A means m, B means 2m, C means 3m, D means 4m. Now observe their accelerations. Particle A is moving with an acceleration on the left side. That means it is minus ai cap. Minus, because it is moving along minus x-axis. And what about B? B is going up along the y-axis. So A, J cap, like that. And what about C? C is moving along x-axis. A, I cap, like that. Positive direction. What about D? D is moving down along y-axis. So minus A, J cap. Like that you have to write the vectors in the acceleration in the vector form. That's all. Now do the substitution. So ACM is equal to, substitute the mass, substitute the acceleration. First m into your acceleration minus m into a I cap, and again here again m into our acceleration a j cap, and here again m into 3m into a I cap, പിന്നെ ഇവിടെ minus 4m into a j cap, all divided by total mass. The total mass is here 1 plus 2 plus 3 plus 4. That will be 10m. 10. Total will be 10m. So that's why I am putting 10m. And if you observe carefully, all the m's will get cancelled. Is enough. So now it will be minus ai cap. Of course, I will and okay, it's okay. 2a j cap plus 3a I cap minus 4m j cap, whole divided by 10. At this stage, what you have to do is gather I cap, I bar first. Here 3a I cap, here minus a I cap of 3a and a. So balance എത്തുന്നുണ്ട് 2a I cap. പിന്നെ നമുക്ക് j എടുക്കാം. ഇവിടെ sorry a മതി. a. അപ്പോൾ here 2a. So yeah, correct, and it's correct. Yeah, sir. Now it is 4a j cap and 3a 2a j cap and 4a j cap. 2 minus 4. 2 minus 4 will be minus 2a j cap, whole divided by 10. Like that. Now you can take 2a as common. So when you take 2a as common, 2a by 10 into I cap minus j cap. So 2 gets 2 and gets cancelled. So we are getting a by 5 into I cap minus j cap. So this will be the acceleration of the center of mass. So a by 5 into I cap minus j cap. Correct. Simple mathematics. That's all. So we have to write the accelerations in vector form, and we have to apply the formula. That's all. The next question, again it is based on center of mass. In this question, a circular hole of radius a by 2 is cut off. So we are removing this smaller piece. So we are removing the smaller piece. So previously it was a disc, I hope. Yeah, it is a disc. It's a disc. Previously it was a disc. So in the beginning, the center of mass acts at the center. But when you remove some portion, center of mass will shift. Okay. So the centroid of the center of mass, that's okay, there's a spelling mistake. The centroid of the remaining center of the remaining circular portion with respect to the point O. So they are asking with respect to the point O. First I will do with respect to the centroid, with respect to the center. After that we will find out with respect to O. Okay. So how to do this type of questions? So first it is a disc. So here we are having O. So now think that this is a original disc. For the original disc, where the weight acts, the weight that is mg acts at its center, So it is mg is a type of force acting at the center. Now we are going to remove a by 2. So this now this will be a by 2. A by 2 means but this radius will be a, and in that radius a by 2. So we are going to remove this piece. Its radius will be a by 2. And that removed piece also will have some weight. So we have to find out the mass of the removed disc. And then we have to represent the weight. Okay, so what will be the mass of the removed piece? We know that mass is directly proportional to area. So we'll write here. So we know that mass is equal to, it's a disc, no, it's a disc. Disc means it will be like that. So this will be area, and this will be, area means how much? Pi r square. And this will be the thickness, and of course it will have its density called rho. So m is equal to volume into density, that is volume is nothing but area, surface area into thickness into density. So we can say that m is proportional to r square. M is proportional to r square. But for the smaller piece, r is reduces to 1 by 2. So how do you write this? Mass of the smaller piece dash by mass of the original piece m is equal to here a by 2, here a by 2, a by 2 by a the whole square. So a gets cancelled. We are getting 1/4. 1/4. So the mass of the removed piece will be 1/4 of the mass of the original disc. So then what will be its weight? Therefore its weight will be mg by 4. Follow. So its weight will be mg by 4. Where it will act? It will act its own center, like that. But now once you remove this portion, center of gravity will shift. So that displacement we want. Okay. So let us assume that shift in the center of center of mass or center of gravity. So let us assume that x is the shift in the center of gravity from C to left side. How to find out that? For that what you have to do? We have to apply what? So we have to apply the position of center of gravity. Come on. So xcm. What is xcm? Xcm is the displacement of the center of mass. But generally, how do you write xcm? Xcm is equal to m1 x1 plus m2. Generally, we will write plus. Why plus? Why plus? When you add two particles, we have to say plus. But here we are not adding. We are subtracting. We are subtracting the smaller piece from the bigger one. So we have to say minus m1 x1 by, so difference mass will be m1 minus m2. Like that we have to apply. But again another problem is I don't know the exact mass. Mass is directly proportional to area. So m can be replaced by a1 x1 minus a2 x2 whole divided by a1 minus a2. Like that we have to do the formula modulation. Okay. Then what is a1? a1 is the area of the bigger piece. So pi a square. What is a2? a2 is the area of the smaller piece. Pi into a by 2 the whole square. A square by 4. A square by 4. Then what is x1? x1 is the position I am taking from the center. Ma'am is doing this from center. From the center I am doing. I am doing from, not from O. I am doing from C. Ma'am is doing from C. After that she will go the formula in O. So what is C1? C1 is the position of mg. So it is exactly passing through. So x1 is equal to 0. Then what is x2? x2 is the position of the center of gravity of second piece from C. That is at a distance of a by 2. See in the figure, it is at a distance of a by 2. Whereas this is passing through. If it is passing through, there is no position, 0. But this is little bit far. Therefore, this distance we can take it as x2, like that. So now you just apply the formula, that is equal to x1 0 LA. So this term vanishes. Minus. Why minus? Because the center of gravity will shift toward the left side. a2. What is a2? It is pi into a square by 4 into x2. x2 is nothing but a by 2. Already I wrote it here. And again a1. What is a1? Pi a square minus what is a2? Pi a square by 4. Like that you have to write. Okay, so now it will be minus. Minus means with respect to C, it is moving towards left. So pi a square by 4 into a by 2. And when you do this simplification, 1 minus 1 by 4, 3 by 4, pi a square, you will get it. So now pi a square by 4, pi a square by 4 gets cancelled. We are getting minus a by 6. But this is the minus a by 6 from C. Why minus? Left. From C. But they don't want from C. They want from O. Okay. So that is simply mathematics. Yeah. So draw a line. This is O. This is C. But what the gap between O and C? The gap between O and C is A. But what the shift in the position of center of gravity? Minus A by 6. This one, minus A by 6. But they are asking the position of center of gravity from O. From O. So what you have to do? From O. From O means OG. OG gitta vendi OC minus GC. Correct. What is OC? A. What is GC? Minus vanda. Minus vanda, because minus represent only the direction. It will be A by 6. A by 6. So A minus A by 6. A minus A by 6 will be how much? 5A by 6. So with respect to O, it will be at 5 by 6A. But with respect to the center of the disk, it will be at a distance of A by 6 and it will be shifted towards left side, like that. In any way they can ask, but they ask with O, like that. In this way you have to do. The next question, it is also almost all same work only. Come on, if you draw the figure you can understand. 2 blocks of masses 10 kg, okay. So block M 10 kgs and block 2 30 kgs. 30 kgs are placed on the same straight line with the coordinates 0, 0 and x 0. It's okay. Okay. The block 10 kg is moved. It is moving with a distance of 6. So x1 is equal to 6 centimeters. Then what the moment of 30 kgs? Okay. So this is called relative. With M1 is moving a distance of 6 with respect to M2. So I want to know the displacement of M2 under the condition that must be moved to keep the position of center of mass. So previously M1, M2 were at some distance. Then we'll have center of mass. When M1 starts moving, M2 also move, but the center of mass should not change. So the position of center of mass should not change. That means what? There should not be any relative displacement of the center of mass. So center of mass should not move. It is a relative word. So 0. Okay, so it should be at the same point. This point. It should be at the same point, 0. If that is the condition, tell me the displacement of M2. Okay, simple again. Okay, let us assume that displacement of M2 will be x2. Everything relative words, relative with respect to one another. We know that again xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. But xcm is 0. So 0 is equal to m1 x1 plus m2 x2 by m1 plus m2. It will carry. Yes. So now put 0 is equal to, what is m1? 10 into what is his relative distance? 6 plus 30 into x2. So that is x2 is the relative displacement of m2 with respect to m1. So that xm will be 0. Come on, solve. So 30 x2 will be equal to minus 60. So what is x2? x2 will be minus 2 centimeters. Yeah. So in which direction m2 will move? M2 will travel a distance of 2 centimeters towards left in the direction of M1. So it moves 2 centimeters towards M, like that. That's all. Simple. Only thing is you have to understand the meaning of that. And this question is our moment of inertia. Yeah, come on. So now read the question. A circular hole of radius r by 4, this is r by 4, is made in a thin uniform disc. Previously it was a disc. But disc ku mass undu, disc ku radius undu. Okay. As shown in the figure. We want to know what the moment of inertia of the remaining portion of the disc about an axis passing through the center. So we want to know what the moment of inertia at O. Okay. How to do this? This we had to do in 3 sections. First, we had to do the moment of inertia for the whole piece. After that, we had to do the moment. First, we had to do for whole piece. After that we have to do for the removed piece. If this is the, after that we have to do for the removed piece, where we had to do at the center. After that we have to shift it toward the center, because when you subtract moment of inertia, we have to do the subtraction only at a common axis. Okay, so first we will find out the moment of inertia of the whole disk at O. After that we will find out the moment of inertia of the small disk at O. At O. After that we will subtract. Okay, so I will do, come on. So first you take this. Okay, so what is the moment of inertia of the whole disk? The moment of inertia of the whole disk is nothing but m is the mass, r is the radius, mr square by 2. At O. At O. That word is important. At O. But next what you have to do? Next we are going to, how much it is? R by 4. R by 4. R by 4. Yeah, R by 4. R by 4 means very small. R by 4. So this radius is r by 4, but the total is r. Therefore, the remaining distance will be 3r by 4. First, I will find out the moment of inertia of the removed piece. Removed piece. Going to removed piece. At this. After that, that should be shifted to this. Okay. That can be done with parallel axis theorem. Okay. First, Ig kandikya. Then ma square apply cheya. Okay. But for that we want to know the mass of the disk. Okay. So what will be the mass of m dash? What will be the mass of the smaller disk? Just now I said mass is directly proportional to the area radius. So m dash by m is equal to r by 4 by r the whole square, because r by 4 radius. 1 by 16. So what is the mass of the small piece? Mass of the small piece will be m by 16. Confirm. Appo mass m by 16, ayaloda radius r by 4. Okay. Appo idu namukku endha cheyyam? Namukku ee portion il cheyyam. Aadham ivide cheyidittu pinne ingane shift cheyidu kodukkanam. Idu O. Idu O alla, idu O dash. First we have to find out Ig value. Ig. So because we are applying the parallelogram. I is equal to Ig plus m a square. That concept we are applying. What is Ig? Ig is the moment of the small piece at O. Which formula? What is the formula? The formula will be mr square by 2. Discale. Appa m sthanathu m by 16 idana. R sthanathu r by 4 idana. Appa namukku Ig kittum. Come on, very carefully we have to do m by 16 into r sthanathu r by 4 the whole square idana by 2 idana. But that is the moment of inertia of the small disk at O. No, I have to send it to the center, because the other one is at the center. Okay, so now I have to apply parallel axis theorem. For the parallel axis theorem, again teacher mass venam. What is the mass of that small disk? 16. And here the distance venam. Here the distance ethanunde. Here the distance 3r by 4. That ingane square cheyide kudukanam. Okay. Appo namakku moment of the small disk at the center gittum. Okay. Calculation, be careful. What is the 60 m unde, r square unde, what is the 16 unde, you want to change langana idum 16 unde or 2 unde. Alpa neighbor varambo m unde, r square unde or 9 unde, mean to 16 into 4 into 4 16 unde. 16 unde cheyanda. Appo idu engan cheyan pettum? M into common edukka pattern theorem mr square by 16 into 16 unde. Appo mr square by 16 into 16 edukkambo teacher kuda 1 by 2 gitti adu illadode 9 unde 9 ittada. Appo mr square 16 imponu cheyanda. 16 into 16 appo idu ethana varum? LCM edukkoda 2 unde 19 varum. Okay. So for the small piece, what the moment of inertia? 19 by 2 into 16 into 16 into m r square. Okay. So now we know the moment of inertia of the whole piece at O, and we know the moment of inertia of the small disk at O. So both are at O. So we can subtract. Now we can subtract. Subtract cheyambo we'll get the resultant. Therefore, the moment of inertia of the resulting piece, moment of inertia of the resulting piece will be moment of inertia of the whole piece minus moment of inertia of the small disk at O. That at O every time we have to see. So that is equal to what the moment of inertia of the whole disk, mr square by 2, and the other one will be 19 by 2 into mr square by 16 into 16. Okay, now we'll do the calculation. Again, what I will do, take the common letter, mr square by 2 I have taken 1 minus 19 by 16 into 16, that's all. Now do the calculation, mr square by 2, we know that 16 and 16 will be how much? 256. So this is 256 minus 19. Okay, yes. So now let me do the calculation here. There is no space there. So 16 into 16, 256. 256 into 2 will be 512. And 256 minus 19 will be how much? 237 into mr square. So the answer will be 237 into mr square by 512. So this will be the answer. Like that you are supposed to do. First find out the moment of inertia of the original disk. After that find out the moment of inertia of the disk about the center and then subtract. So when you do this calculation, you should be very careful about the mass and of course calculation. The next question is also based on moment of inertia. 7 identical circular discs, each of mass m and radius r, are arranged as shown in the figure. Total we are having 7. At the center we are having 1. Surrounding that we are having 6. I want to know what the moment of inertia at this point. Yes, again, first disk, central edka. Of course 1, put the number, 2, 3, easy for you to understand, 4, of course 5, 6. Namku evada vendadu? Ivadana vendadu. Kuti perpendicular, normal, try to understand, ivadana vendadu. Engane, first what you have to again, like, we have to combine all the moment of inertia of the center. Pinna from the center full shift cheyanam. Complete mass angote shift cheyanam. Appo first namukku center la kandupidikka. Center. Appo ivide center la kandupidikka. Center la kandupidichittu pinna angote shift cheyidu kodukanam. Okay. So then we have to apply the parallel axis theorem. Okay. And each is having a radius r. So this is r. This is also r. This is also r. So this distance will be from here to here. From the center to this it will be 3r. Center to this will be 3r. This will be 3r. That will be 3r. Now first center la kandupidikka. Center engane kandupidikkan bettu? Come on. Center engane kandupidikka? Moment of inertia of the system at the center. Moment of inertia of the center is equal to, at the center we are having one disk. That will be m r square by 2. And baki ethana undu? R anna undu. 6 undu. And we have to shift their moment of inertia. Baki means, let me teach for this. Suppose when you at this axis, any one. So at this axis, how much you are having? mr square by 2. But namukku ivada venda. Ivada shift cheyakodum. We have to shift it. Idu final. Now I am doing original. Okay. So this is the center. This is the fifth one. I know moment of inertia at this point. So it is mr square by 2. So again we have to apply parallel axis theorem for all the 6. Moment of inertia of all the 6 should be gathered at the center. Center plus moment of inertia of the all the 6. Kandupidichittu pinna final at angote shift cheyidu kodukanam. Okay. So now, okay, this is the moment of inertia of one of the disk, that is at the 1, 2, 3, 4, 5. But that is not at the center. So that is at their own, at their centers in a shift. Shift time what you have to do? We have to apply parallel axis theorem. So m into, now the gap will be from here to here. Now the gap is from here to here. From here to here it will be 2r. From here to here it will be 2r. So we'll write that as 2r the whole square. Okay, this again I repeat. This is moment of inertia of the center disk, and this is all the moment of inertia of the other disk towards the center, like that. But now if you ask me to do the derivation, this is 1 by, this is how much? 6 mr square by 2, 1 mr square by 2. So then it will be 7 mr square by 2 plus, and this will be 2 into 2, 4, 4 into that 24 mr square. And if you ask me to do the derivation that, so this will be 2, this will be 48, so this will be 55 mr square. That is 55 mr square. Now what you have to do, let see, this is the center, but we don't want at the center, we want at P. So again this value, that is our 55 mr square by 2, the complete you have to shift it to a distance of 3r. The complete mass, what is complete mass? Mass of the system. Now what is the mass of the system? It is made up of 7 disks. Mass of each disk will be 1. So the complete mass 7m, you have to shift it. Understood? So this is Ig value plus ma square apply cheyambo, m in the mass of the system, 7m plus distance square, like that you have to do. So the moment of inertia of the system at the point P will be moment of inertia of the system at the center. Center namal nertha kandupidichu. This is the moment of inertia of the system at the center. Now we are going to shift. We have to apply ma square. What is m? It's not a single disk. It is made up of 7 disks. So we have to take 7m. 7m into distance. But the distance is from center to edge. So it will be 3r. It is not, because this is diameter 2r and this is r. So it will be 3r the whole square, like that. So again calculation, 55 by 2 plus, so this will be 3 into 3, 9, 9 into 7 into mr square. So let us see how much we'll get. So this will be 2, so this will be that, and here 6, here 12, plus here 55. How much I am getting? Yeah, 181 by 2. Is it correct? 181 by 2. Yes, 181 by 2 mr square. Correct. So I got exactly 181 by 2 mr square. You please go through. Okay. First do for the central disk. After do the neighboring disk. For that you have to apply parallel axis theorem to get it to the center. Again the whole center you have to shift it. So again you have to apply parallel axis theorem. And this is a little bit simple only. Come on. A string is wound around a cylinder, hollow cylinder. Hollow cylinder moment of inertia is one the same as ring, mr square of mass. So let us assume that this is a cylinder. They gave m is equal to 5, r is equal to that. A string is pulled like this, horizontally, horizontal force, 40 newtons they give. Okay. And angular acceleration, we want to know what is it, because when you apply the force, what happens? It will rotate, it will have omega. So I want to know what the angular acceleration. When you want angular acceleration, apply the torque concept. So we are having two concepts. One is torque is equal to force into perpendicular distance, other one is I alpha. Okay. So now first, so this will be the radius. So now torque, we know that torque is equal to force into perpendicular distance. So we will get Fr. And there is another formula for torque. Torque is equal to I alpha. But this is hollow cylinder. Na? For hollow cylinder, it is one the same as ring. So I am putting mr square. So we will equate. So this is the first equation. And this is the second equation. So Rf is equal to I. I is nothing but mr square into alpha. RR gets cancelled. Alpha 11 to the F by mr, like that. So F is how much? 40 newtons. And M is how much? 5 kgs. R is how much? 0.5. That I will write it as 1 by 2. So we are getting 80 by 5. 80 by 5 is nothing but 16. 16 will be the answer. Like that. Okay, if you know the concept, this will be very easy. Again, see, this is very simple. We want to know what the radius of gyration of the rod about an axis passing at a distance of L by 4 from the edge, from the center. Okay, we can do. So we'll have a rod and this is the center, but we know that the moment of inertia of the rod at the center will be ml square by 12. Okay, but we want at L by 4. So L by 4. So this will be L by 4. So we have to shift it. So we have to apply parallel axis theorem. So the moment of inertia will be moment of inertia at the center ml square by 12 plus ma square. Ma square. A is nothing but L by 4 the whole square. Come on. So first we'll find out moment of inertia. After that we'll find out the radius of gyration. So it is ml square by 16. Okay na? So that will be equal to, I will go for LCM as 48 and this will be 3 or 4, it doesn't matter, and of course that will be 3. It doesn't matter. Okay, it's okay. Yeah. So you are getting it as 7 by 48 into ml square. But I want radius of gyration. So what is the general formula for moment of inertia? Mk square. So that mk square will be compared with the it will be compared with the moment of inertia which we got it. So that is the procedure to find out the radius of gyration. So k square is equal to so and so. K will be equal to root of 7 by 48 into L. Root of 7 by 48 into L. Correct. Root of 7 by 48 into L. We got it like that. Very easy only. Yeah. And this is good question. We have to apply moment of force. Just read the question. We are having a rod. Rod is suspended from a point X. Yeah, it's a point X. This is a point X. And it is at a distance of X units. That's also very important. And to make the rod horizontal, a mass M is suspended. Okay, here we are having a mass. So mass, we are having a mass. Mass means we don't want mass, we want weight. So I took mg. So mg is at a distance of mg. Mg is at a distance of x from this particular point. At the central. Don't think that it's a center. Don't think that it's a center. A set of what they are asking. They want to plot a graph. They want to plot a graph. They want to plot a graph between m and x. M and x. Okay. They want to plot a graph between a set of m and x. So they are collecting the values of m and x. It's okay. The appropriate variable that makes a straight line. So we have to collect m value, x value, so that they want straight line only. We have to put it in the form of y is equal to mx plus c. Then what should be the coordinates? What should be x coordinate? What should be the y coordinate? How do you plot the graph? Can you take m on y axis, or can you take x on y axis, x on x axis, or can you take 1 by x on y axis? That's what they are doing. Can you take m on y axis, or can you take 1 by x or 1 by x square on x axis? That's what they are telling. That and all we can tell only when you write it in y is equal to mx plus c. Okay, so we'll try to write it in mx plus c. So m is a variable, x is also a variable. M and x are variable. We'll see the equation. Okay. So for that, what we have to do is we want relation between m and x. Okay. So we have to balance this. So now, of course, we'll have the weight of the rod. Where the weight of the rod acts, the weight of the rod I will take it as m. Weight of the rod I will take it as m. So that will be mg. M is the weight of the rod, and it will act at the center. So what is this distance? This distance is L by 2. So what will be this distance? This distance will be L by 2 minus x, like that. And now what we will do? We will apply moment of forces, or moment of force acting in the clockwise direction is equal to moment of forces acting in the anti-clockwise direction. So that the system will be at equilibrium, or sigma tau z is equal to 0. In any way we can tell. And then apply I got one idea. Actually it is r bar cross f bar direction only, but I will do very fast. See, first I will always move from perpendicular to force. Okay. So this is r, this is f, like this, like that I will get it. And this is r, this is up, like this I will get it. Okay. This is the clock, this is the anti-clock. Sum of the forces in the clockwise direction is equal to sum of the forces acting in the anti-clockwise direction. X into mg, or mg into x, because force into perpendicular distance is one the same as L by 2 minus X into mg. Again, perpendicular distance into force, or force into perpendicular distance. So now G and G gets cancelled. But I want to know the relation between small m and x. In this situation, capital M is constant. So let me divide with x. So when I divide with x, if you want, you can take m inside. So m L by 2x minus x divided cut m gittum. The formula that should be in the form of straight line. That should be in the form of straight line. So it should be in the form of straight line. It should be in the form of mx plus c. It must be in the form of mx plus c. Appa y coordinate edayirikkum? No, okay, just y coordinate edayirikkum. So then what will be the y coordinate? Y coordinate namukku m aayittu edukka. But x coordinate engane eda x coordinate? But x tayottundu. Appa idu x, idu vere x ingane idam, capital idam. Math students, you can understand. Appa namukku x nu vandu numerator il venum. Okay. Appa x coordinate engane edukka? X coordinate is 1 by x edutha pore. A 1 by x nu vandu x side edukkumbo, a 1 by x nu varayundu x side edukkumbo, appa idu edu formula varum? Y is equal to edo or constant into mx plus c. A formula kittathille kittu. Understood? So they want this relation in the form of straight line. So m should be plotted on a y-axis. 1 by x has taken as x, then it will be a straight line. So what are the coordinates? M should be taken on y-axis and x should be taken on x-axis. So these are all the variables we have to plot on the x-axis and y-axis. That's what they meant. So the answer is m and 1 by 5, like that. The appropriate variables means what? M variables, x variables, AT graph, acceleration and time, that type of variables, like that. So m should be on y-axis, 1 by x should be on x-axis. Then only it will be in the form of y is equal to mx plus c. And similar question once again they are putting, okay, shown in the figure, 1 meter rod, 1 meter, exactly 1 meter, length of the rod is given, is in the horizontal portion by 2 strings tied to the end. So we are having 2 strings. So draw the figure. So we are rigid. So we are having 2 strings. So definitely they will have their tension. T1 and T2 are there. Okay. And A is at a reading of 0. Okay. The rod of mass M. So we are having the rod of mass M and another mass of weight 2m. So m is the mass of the rod, 2m is the mass of the stone. So where is your 2m? Your 2m is at a distance of 75 centimeters, whatever it may be. And we have to consider the weight of the rod. The weight of the rod is always acts at the center. So that will be at a distance of 50 centimeters. Because the total length is 100 centimeters, 1 meter. So the weight will act at 50 centimeters. So then what is the tension in the string? Correct. Again same only. First what you have to do, it should be at equilibrium. Okay, it should be in the horizontal position. Okay, so upward forces are equal to downward forces. So forces means I have to put G, here. Okay, forces means I have to put G. Okay, so now upward forces T1 plus T2 is nothing but downward forces mg plus 2mg. So it will be 3mg. Call that as first equation. But I don't want T2, I want T1. So I have to eliminate T2. So what concept I can apply? Apply torque concept, because the system is at equilibrium. So sigma tau is equal to 0. Sigma tau is equal to 0 means moment of forces in the anti-clockwise direction is one of the same as moment of forces in the clockwise direction. That engane cheyan pettu? Edengil oru point reference aayittu edukka. Any point you can take. So now I will take any point you can take. I will take A as the reference point. And now just think of the forces. Okay. Yeah, we want perpendicular distance into force. Suppose if this is the point, if this is the force, then there is no torque because the force is acting through the point. Appa namakku perpendicular distance illa. Okay, that happens in T1 here. Okay, so I will take O. So I will do, look, I am moving it this way. How to move? Come on again. So this will be the 50, this is perpendicular distance and this is force. So the direction will be like this. Again this will be perpendicular distance, this will be force, this will be the direction. But this will be 100 because it is at the edge. this will be like, so this will come out as anti, this will come out as clock, like that. And what about T1? T1 is a moment of force illa, because T1 is passing through the point. There is no distance, like that. So applying moment of force at O, at A, 0, T1 illa, plus mg konde ethanunde 50 into mg, and 2 mg konde 75 into 2 mg. These are all the moment of forces in the clockwise direction. That should be balanced by the moment of force in the anti-clockwise direction. That is T2. T2 is at the end, so that will be 100 into T2. So now can T2 kandupidikkan pettum. Ready na? So this is how much? 150. This is how much? 50. 150 plus 50 will be 200. 200 mg is equal to 100 T2. So T2 will be equal to 2 mg. So you got the value of T2. Now we want T1. So put it in the first equation. That's all. So T1 plus 2 mg is equal to 3 mg. So T1 is equal to how much? 1 mg. So T1 is equal to 1 mg. So T1 is equal to 1 mg. Like that. That's all. Very simple. We have to apply the moment of forces. I took A as the reference. If you want, you can take center also as the reference. Then you will get again T1, T2. Again you have to solve it. Like that. So, okay. Yeah. And this question we have to do based on law of conservation of angular momentum. What is law of conservation of angular momentum? I1 omega 1 plus I1 omega 1 is equal to I2 omega 2 before and after. Okay. That and all we might have disc for, you might have did for disc ring. Now they are asking for rod. That's all. Come on. Come on. A smooth rod of length L. Okay. Length L. Mass M. M is the mass. L is the length. E is rotating freely about its angular velocity omega. Okay. Yes. But now what is I1? Now I1 will be rod LA ml square by 12. And what is omega 1? That is omega naught. That is before. After that we are going to make some changes. Then 2 beads, each of mass M, another M, are kept at the say at the center or the initially. These beads are free to slide along the rod. The angular speed of the system, when the beads reaches the opposite end. Now the beads are at the end. Okay, so as the beads move away, what happens? The distribution of the particles increases, moment of inertia increases, angular velocity may decrease, angular speed may decrease. So again the second figure will be, so this is the moment of inertia of the rod, ml square by 12. In addition to that, we are having 2 beads, and m is the mass of the bead. Of course, it is distributed again L by 2, again another mass. So these beads should be considered as point masses. For point masses, we have to apply mr square concept. Now what is the moment? Now of course whole system is rotating, and I want to know what the moment of inertia of the second system. Here what is the moment of inertia of the system? Moment of inertia of the rod plus moment of inertia of the beads. But the beads are at a distance of L by 2. So we will apply mr square concept. Like that, how many are there? We are having 2. 2 into m into r square. L by 2 the whole square. That formula we have to apply. Okay na? Yeah, let it be. And omega will be, omega 2 will be, we have to find out. Omega dash we have to. So now what the concept? We are applying law of conservation of angular momentum. That means I1 omega 1 is equal to I2 omega 2. Now just substitute the values. I1 is ready, I2 is ready, omega 1 is ready, omega 2 now kandupidikka. Come on, substitute the values. So that is ml square by 12 into omega naught is equal to, be careful, put the bracket, ml square by 12 plus, if you want you can do the squaring, L square by 4, 2 gets cancelled, ml square by 2, okay now, into omega dash. Yeah, so now L square gets cancelled. Now take the LCM, after that you can do the cancellation. Now don't do the cross multiply. Take the LCM, when I take the LCM, it will be 12, it will be m, and it will be 6m, and of course it is followed by omega dash. Now this 12 gets cancelled. So omega dash will be equal to m into omega naught by m plus 6m. So that will be angular velocity when the two beads are moving towards the ends. So the answer is m omega naught by m plus 6m. So the answer will be 4, like that. Next, here in this question, small error is there. It will be minus. You can guess it. It doesn't matter. It's not a big issue. It's a minus. That's all. That under minus. Okay. It is also similar to that, but we have to do. Come on. Two coaxial disc. For disc, the moment of inertia is mr square by 2. Having moment of inertia, so we are having first disc. Okay, of course rotating I1. We are having second disc rotating with how much? I1 by 2. Okay, and they are rotating with, one is rotating with omega 1, other is rotating with omega 1 by 2. And this is before and after. This is bigger. After that, what happens? They are brought in contact and they rotate. That means both the discs are together. See, both the discs are together. They are rotating. But I don't know what is omega. Of course, they have given their individual moment of inertia, I1 and I1 by 2. This is after. This is before. This figure is before. And this figure is after. You have to see. That's why I am writing on whiteboard. Okay. So they are asking then, what is the difference of energy? Energy means rotational kinetic energy before and rotational kinetic energy after. Final. So what you have to first will do for before. Before will be, before means initial. Ki. For Ki, half into I1 into omega 1 square plus half into I means I1 by 2 into omega 1 the whole square by 4, because the formula is half I omega square. So this will come out as how much? Half into I1 into omega 1 the whole square. I will take it as common. 1 plus baki ethanundu 1 by 8. That correct. So this will come out as, it is 9 by 8. 9 by 16 I1 omega 1 the whole square. That is the initial kinetic energy of the system. And like that we have to find out the final kinetic energy of the system. Again we have to apply half into moment of inertia of the system into angular velocity of the system. But we have to find out omega. Omega they have not given. So to find out omega, what you have to do? I have to apply law of conservation of momentum. I have to apply law of conservation of momentum. If you apply law of conservation of momentum, then only you will get omega. Okay. So how to apply law of conservation of momentum? Momentum of the first one, I1 omega 1. Momentum of the second one, I1 is I1 by 2. Omega means omega 1 by 2 is equal to, now they are combined. So combined mass of moment of inertia into common angular speed. So then it will be, oh my god, sorry, I1 by 2 into omega 1 by 2 is equal to combine. Combine means what? I1 plus I1 by 2 into omega. So if you apply law of conservation of momentum, then only you will get it. 1 plus 1 by 4. 1 plus 1 by 4, how much? It is 5 by 4 I1 omega 1. 1 plus 1 by 2. 1 plus 1 by 2 will be 3 by 2 I1 omega. Now I1 gets cancelled. 2 gets cancelled. Okay. So omega will be 5 by 6 omega 1. So this is the angular speed of the combined system. Now again you have to find out kinetic energy. The kinetic energy of what? Kinetic energy for the system. That will be half into moment of inertia of the system. I1 plus I1 by 2 into omega square. We have to put like that. So that will be again half into 3I1 by 2 into omega square. Omega square. This will be squared. That will be 25 by 36 into omega 1 square. Okay, now this will go by 12. Okay, now. So we'll get 25 by what? 4 into 12. 4 into 12, how much? 48. Omega 1 square. So this will be the I1, yes. Yeah, so this is the final kinetic energy, okay, of the system. But they are asking for difference, okay. If the initial is more, we'll get positive. If the initial is more, we'll get negative. If the initial is less, we'll get positive. Okay. So let us see what happens. So Kf minus Ki. What is Kf? 25 by 48. Of course, I1 omega 1 is common. What is final? Minus 9 by 16 into I1 omega 1 the whole square. Now take the LCM. LCM is 48. So you would have 45, you would have 27. No, here 25, sorry. Here 48, so there is no LCM. I said 48, so yeah. Into I1 omega 1 the whole square. So I am getting minus. Minus, it is 2 by 48 into I1 omega 1 square. Again, if you ask me to do the cancellation, it is minus 1 by 14 into I1 omega 1 square. Why we are getting negative? Because initial is more than final. So 1 by 14 into that, yeah. No, 1 by 24. 2 ones and 2 ones are. So it is 1 by 24 into I1 over. Exact answer is minus, but you can guess it. Nothing wrong in that. Okay. In this way, you have to do. Very carefully we are supposed to do. Okay. Yeah. So find out. So we have to apply. First of all, you have to find out total kinetic energy. Again, we have to apply conservation of angular momentum to get omega. Again, we have to find out final. Again, we have to subtract. Okay. And this question, you should have idea about the formula. Then only you can do. Solid sphere and solid cylinder. We are having solid sphere and we are having solid cylinder of identical radii. Okay, radius is same. Approaching an inclined plane with the same initial velocity. Both are having the same. Velocity of the solid sphere is one and the same as velocity of the cylinder at this point. So they want to know what the maximum height attained by them. What is the maximum height attained by them? Correct. So you should have idea about velocity with which the solid sphere reaches the bottom of the inclined surface. It may be ascending or it may be descending. Same formula we can apply. That you can refer. So we have already studied that velocity of the solid sphere will be root of 10 by 7 GH. You can have a formula. Formula apply cheyadamade. Root of 2 GH by 1 plus I by mr square. Of course, some people will use k square by r square. Some people will use some alpha like that. For solid sphere, you have to apply 2 by 5 mr square. Then you will get it. Similarly, if you ask me to do hollow sphere, if you ask me to do for cylinder, solid cylinder is one the same as a disc. So I have to put mr square by 2. Then you will get 4 by 3 GH. These are all the formula we have to apply. But in this case, these two are equal. They are equal. But this may be different. That we have to find out. That's all. They are equal na. So I will equate it. They are equal na. So we will equate it. So when you equate it, we will get the expression like this. Root of. Yeah, now solve for HS and H. And so to avoid square root, we will square it on both sides. So then what happens? G and G gets cancelled. And now your expression will be 10 by 7 height attained by the solid sphere will be 4 by 3 height attained by the cylinder. But they want to know what the ratio of height attained by the solid sphere with respect to the height attained by the cylinder. If you want, you can cancel here itself. Nothing wrong in that. So now H, height attained by the solid sphere, bring this to this side. Height attained by the cylinder is equal to do the cross multiplication. So it will be 7 into 2, 14, by 5 into 3, 15. Okay. So when they're all moving at the bottom with the same velocity, they will attain their respective heights, but the heights will be in the ratio 14 is to 15. 14 is to 15 will be the correct answer. Okay, na? Yes. Okay, students, we'll continue with the 19th question. Okay. So here we have to do a lot of things. Okay. Again, read the question. So we are having a, no need to see all these things. Okay, we are having what? Flywheel. Flywheel, immediately they said disc. So disc. So for disc, what is the moment of inertia? They have given small m. Okay. Anything, the m r square by 2. So we will start thinking from moment of inertia. So disc, and of course they have given the radius and m. This both are m only. Okay. So both. So mass of the disc, mass of the body same. Be careful. Mass of the disc, mass of the body are same. And when it has, when you remove it, it will. When you remove it, the body will go down. So after traveling a distance of h, tell me what is the angular velocity. We want to know what the angular velocity is after when the hanging body travels a distance of h. But direct omega. First we will find out v. V is equal to r omega. No? So, okay. First we will find out v. What is v? V is the linear velocity after traveling a distance of h. So we will find out v. After that we will find out v. After that we will find out omega. But how to v? To find out v, we have to find out acceleration. First we have to find out the acceleration of the falling body, and then we have to find out the velocity of the falling body. After that only we have to connect that with y is equal to r omega, like that. Now the question is how to find out the acceleration of the falling body. Come on, m is there. First to draw the figure. This is mg and this is tension in the string. Let us assume that it is moving with an acceleration a. Immediately we have to write the equation of motion. But we know that once this is action, this will be reaction. But that reaction is acting exactly at a perpendicular distance of r for the disc. Due to that, it will have a turning effect. So that T and R we can apply for torque. So we will have two ends. One is linear equation, other one is angular equation. Angular equation we have to convert into linear equation. So first we will write the linear equation. mg minus T for tension, is equal to ma. Okay. Now you won't get T directly, you will get T in terms of tau. Torque. Tau is equal to force into perpendicular distance, RT. But that can also be written as I alpha. What is I? Moment of inertia of the this. That is RT is equal to I into. But what the relation between alpha and A? We know that A is equal to R alpha. So alpha is equal to A by R. Therefore T is equal to IA by R square. IA by R square. Okay na? What is I? I is nothing but moment of inertia of the disc. How much? It is m R square by 2 into A by R square. So R square gets cancelled. So what is T? T will be equal to ma by 2, like that. Or if you do this already in the class, and if you have a standard formula, you can apply also. Nothing wrong in that. Sometimes we'll do for different bodies, sometimes we'll do for same body, anything you can do. Now I want acceleration, so I will add it. So it will be mg is equal to, when you add it to 1 plus that, it is 3 by 2 ma. So ma gets cancelled, we are getting acceleration. So the acceleration will be 2 by 3 g. So like that I got the formula for acceleration. Next what you have to do, have to find out velocity after it travels a distance of s. But the initial velocity will be 0. Mostly initial velocity will be 0. So u is equal to 0. So v square is equal to u square plus 2as. That concept I am applying. Therefore v square is equal to 0 plus 2 into a. A is nothing but 2 by 3 g into h. Okay. So your velocity will be 4 by 3 gh. 4 by 3 gh. So therefore velocity will be equal to root of 4 by 3 GH. So we reach root of 4 by 3 GH. So we reach up to the linear velocity. But they don't want linear velocity, they want angular velocity. So what the relation between linear velocity and angular velocity? V is equal to R omega. So what is omega? V by R. In V term. So R into root of, what is V? 4 by 3 GH. So what will be the angular velocity? Angular velocity will be equal to 1 by R into root of 4 by 3 GH. 1 by R into root of 4 by 3 GH. Look. Super at kittanundu. Okay. Yeah, and this is very simple only, don't worry. Yeah, uniform sphere. So we are going to do the work with sphere, and mass is in grams, will convert into kilogram, and velocity is in centimeter, that also will convert into meter. They want to know the kinetic energy. It's a rolling, rotational. No, it's not. Without slipping on a plane, horizontal surface with the center is moving. That means what? The sphere is rotating. It is rotating, and it is moving forward. It is rotating and it is moving forward. So we have to take both translation as well as rotation. Okay, so the total kinetic energy will be both translation as well as rotation. And we will change it down. It will be 7 by 10 mv square. Okay, that will be equal to 7 by 10 into mass is nothing but 500 grams. Convert into kilogram. Velocity is 5 into 5, but that is in centimeter. Convert into meter. So if you do the calculation, you will get it, because this will be how much? 125 into 7, 8, around 8 you will get it. You can do that. Okay. Yeah, the next question will be, see that F is equal to 5y plus 20 j cap. Why they gave j cap? Because it is acting along y axis. Okay, if it is acting along y axis, so we have to do the integration with respect to y. We have to do the integration with respect to y axis. So that is the beauty of this question. Okay, what is the work done by this force when the particle moves from y is equal to 0 to y is equal to 10? So previously we used to do with respect to x, f dx. We should not do with f dx, we have to do with f dy, because it is moving along y axis. So w is equal to integral of f dy, of course between the limits y1 to y2. That is integral of 5y plus 20 into dy between the limit 0 to 10. Like that you have to do. That's all. Rest of these things we will do. Integration, y integration will be y square by 2. 20 into 1 integration will be between the limit 0 to 10. You can do. That is 5 by 2 into, that is 100 plus 20 into 10. Of course the other will be 0 plus 0. So this will be how much? This will be 100. No, this will be 50 now. So this will be 250 plus this will be 200. Overall you are getting 400. So sorry. This will be 250 plus 200. Overall you are getting 450. 450 will be the answer, like that. So the only thing is you have to do with respect to y. Come on, next question. A body of mass 2 kgs object, so that its position is given by x is equal to 3t square plus 5. So they gave position vector of the particle. What is the work done by this in the first 5 seconds? In the first 5 seconds means initial will be 0, after will be 5 seconds. I want to know work done. I want to know work done. But we know that if you know the velocity, we'll have initial kinetic energy, final kinetic energy. So if you apply work energy theorem, kinetic energy is change in kinetic energy is equal to work done, then you will get work done. So that is the concept I am applying here. Easy to do. So we will apply work energy theorem. We will apply work energy theorem. What is this work energy theorem says? Change in kinetic energy is equal to work done. For that I should have initial velocity and final velocity. For that I want velocity equation. So I have to differentiate. I have to differentiate this. If I differentiate this, then only I will get velocity. So differentiate. V is equal to dx by dt. So t square differentiation is 2t, 6t. Then what will be the velocity, initial velocity? T is equal to 0, 0. What is the velocity after 5 seconds? 6 into 5. So that will be 30 meter per second. So I know the initial velocity, I know the final velocity. I can apply work energy theorem to find out work. So work is equal to final kinetic energy minus initial kinetic energy. That means half into m into v square minus 0, because this is 0. That is half into, and what the value of m? 2 into 30 the whole square. So 2 gets cancelled. 30 square will be 900. So like that we got the idea about work done. Okay. Yes. The next question will be, yeah, come on, read it. A block of mass moving with a speed compresses spring through a distance of 30 centimeters when the speed is reduces to half. Then what is the force constant? Better to draw the figure. So we are having a spring here and we are having a body of mass here. Okay. Yeah. Yes. So now that work cheyamo. First it is moving. It is just touch on. So now the body is moving with some velocity. What the velocity? The velocity in the beginning will be 12 meter per second. Okay, so the block is moving with velocity of u1. Therefore, it will have kinetic energy. Now, what is the initial kinetic energy of the body block? That is half into m into u square. It's okay. Okay, and it compresses the spring through a distance of 30 when its velocity reduces to half. After that, what happens? It has in the next figure I am doing. After that, what happens? It is compressing this. See my figure. The spring is compressed. So now at this point, the velocity will be half of the initial velocity. That is 6 meter per second. That means what? Velocity is reduced. Kinetic energy is reduced. Kinetic energy of the block is reduced. So the loss of kinetic energy of the block is converted into potential energy of the spring. That's why the spring is compressed. That's the concept. Okay. So what the final kinetic energy of the block? That will be half into m into v square. So there is a loss of kinetic energy. Loss of kinetic energy for the block. Loss of kinetic energy of the block will be converted into the potential energy of the spring. Loss of kinetic energy of the block will be converted into potential of the spring. That means what? Half into m into u square minus v square will be equal to half into k into x square. But what is x? He is telling the spring travels through a distance of 30. So it is compressed by a distance of 30. So the 30 can be taken as the compression. That's all. Now substitute the values. Half into mass of the block. Mass of the block is 0.5. For my convenience sake, I will write 1 by 2. Into initial velocity is 12 square minus 6 square. Why 6 square? Because of the pagidi aipoi. That is equal to half into, we have to find out k, and the compression is 30 centimeter. So I will write 30. Again I will write 30. Again I will write 10 raised to minus 4. Like that. Yeah, now how to do this? This 1 by 2, this 1 by 2 gets cancelled. So this is 1 by 2 into, it is in the form of a plus b into a minus b. A plus b 18, a minus b 6 is equal to k into 30 and 3 into 3 into 10 raised to minus 2. Adjust that. Now look, you can cancel it. This will go by 9 times. This also will go by 9 times. Finish. We are getting it. So k will be equal to 6 by 10 raised to minus 2. Now take 10 raised to minus 2 to the numerator. So it will be 6 into 10 raised to 2. 6 into 2, 10 raised to 2 will be 100. So the answer will be 100, like that. So here the concept will be loss of kinetic energy in the block will be equal to potential energy stored in the spring. Next question, it's also different. A uniform chain of length, okay. We are having two cases. A uniform chain of length 3 meters. Mass is also important. Mass also we have to consider. Hangs over a smooth table with 2 meters lying on the table. First, in the first case, 2 meters on the table. 2 meters on the table, 1 meter hanging, like that. So you have 2 meters, so you have 1 meter. Be careful. If K is the kinetic energy of the chain in joules, as it completely slips off the table, it is like this, like this, like this. Now what will be the length? It will be 3 meters because the total length is falling. At that time they want to know what the kinetic, it's falling now, they want to know what the kinetic energy. So we'll have gain in kinetic energy. Gain in kinetic energy is equal to loss in potential energy. How to find out potential energy in case of chain on rod? We have to take the moment of center of gravity, okay. So in this case 1 meter, so the center of gravity will be here, G. That means it is at a distance of 0.5 from O. I will take this as the reference level. I will take this as the reference level, okay. Now here potential energy vendadu. Now here potential energy engane potential energy U is equal to here mass, hanging mass into GH. GH1. Now here mass depends on the length. Only 1 meter, it is not whole. For 3 meters what the mass? 3 kgs. For 1 meter what the mass? 1 kg. So here the mass is 1 kg only we have to take. So your mass 1 kg, acceleration equality, and the position will be 0.5. Like that we have to write. In Ingotwa. The whole 3 meters is falling. Where is the center? Now the center is here. That is, it is at a distance of half of the length. It is at a distance of 0.5 meters from the level. Now what the mass? Now 3m is hanging. What the mass? Now the mass will be equal to 3 kgs only. Correct. In this situation, how do you find out the potential energy? Mass 3, acceleration g, and the position will be 1.5. In this way, how to do? Okay. Now we have to take the difference of potential energy. The difference of potential energy will be converted into kinetic energy. That only we have to find out, like that. Okay, understood? So the kinetic energy is equal to difference means U2 minus U1. This is 10 idalo. This is 10. So this 10 idambo, we will get 45 joules. This is 10 idambo, 5 joules. So the answer will be 45 minus 5. So this will be 40 joules. 40 joules will be the gain in the kinetic energy, because that is equal to the loss in the potential energy. But the only thing we have to remember is we have to take the position of center of gravity. Of course here mass changes, that also we have to observe, like that. Next question will be the moment of finish of the hollow cylinder. These words are very important. Hollow cylinder. Hollow cylinder is almost all like ring. And they gave length. We don't want length because the rotation is different. Inner radius and outer radius and okay. Inner I will take it as R1. Outer I will take it as R2. About an axis. Its axis like this. Suppose if you think that this is the hollow cylinder. Okay, inner, so okay, it's okay. Like this. I am rotating about this axis. For this axis, length vanda. If I rotate in this way, then only length is required. Okay. Then what is that formula? Formula is almost all like our ring. The formula will be m into R1 square plus R2 square by 2 Vena. So this is the moment of inertia of the hollow cylinder when they go R1 R2 about this axis, not about this axis, not about this axis. Is high, that is high, that is high. They said it is high. The radius again, the radius of the thin cylinder. It is not thick cylinder, it is a thin cylinder. Okay, so it is a thin. Thin means again what you have to thin. It is not thick. Thick means we'll say it is a solid cylinder. Solid cylinder is one the same as disc. It is not thin, it is not thick, it is thin. So it is a hollow cylinder. Hollow cylinder is one the same as ring. So we'll apply the formula here, mr square, like that. The radius of the thin cylinder of the same mass is one the same, will be what? And such that its moment of inertia is one the same. So he is telling that moment of inertia of the thin cylinder is one the same as moment of inertia of the hollow cylinder having two radii R1 and R2, like that. So when the moment of inertia is one the same, tell me the value of radius of the thin cylinder. Thin means hollow, thick means solid. Solid is same as disc, thin is same as ring. So mr square. But if you have inner and outer, we have to apply this formula. That's all. R and R gets cancelled. So R square is equal to R1 square plus R2 square by 2. Therefore R is equal to root of R1 square plus R2 square by 2. In this condition, L is not required. That's all. Now just do the calculation. No need to convert centimeter because the answer is in centimeter. 10 square plus 20 square by 2. So we know that this is 500 by 2. 500 by 2 will be how much? 250. That will be 5 root 10. Root 10 I can take it as approximately 3.2. Approximately I may get 16. 16 will be the answer, like that. Root 10 approximately 3 LLO, little bit more than 3. Yes. This is no kuti. This is what you have to do. For every value we have to do. And E identity apply cheyam. E identity apply cheyam is X get. Come on. They gave M as the mass, radius 2R. But 2R it complicate cheyanda. 2R namukku vere edhing illa. So let us assume that complicate cheyanda. 2R marayenda namukku vere chumma ida. Because all are having the same radius. Appa 2R cut type. Okay. So no need to write. Appa 2R namukku teacher R dash ethununde. In over night ida. Moment of inertia of the solid sphere about the diameter. So it will be I1 will be equal to 2 by 5 m r dash square. Appa 2R number 4, 8 anganakka varum. Samim kodal edukkum. Appa cut type on, don't wait. 2R dash ittunde. I2 will be equal to solid cylinder about this. Just now I said solid cylinder is not the same as disc. So it will be m r dash square by 2. That is the second value. And moment of inertia of this solid circular disc about the diameter. Disc about the diameter. Original value by 2. mr square by 4. So I3 is equal to m r dash square by 4. Because why r dash? Because r dash is equal to 2r for them. So I don't want to do with 2r. Okay. Next will be moment of inertia of the thin circular ring about the diameter. We know that for ring it is basically it is mr square. Diameter means by 2 chayana. So then it will be again m r square by 2, like that. Okay. Now we have to substitute all the values in this identity. So the identity will be 2 into I2 plus I3 plus I4 is equal to X into I1. If that is the identity, tell me the value of X. That is 2 into I2. What is I2? M into R dash square by 2 plus I3. That is M into R dash square by 4 plus I4. M into R dash square by 2. Why ma'am is writing R dash manslaya? To avoid that 2R into I1. That is 2 by 5 m r dash square, like that. Now see, in all the cases m r dash square, m r dash square, m r dash square, m r. That's why I told no need to write 2r. letters will be complicated. Okay, that's all. So now we'll do the work. So this is 2 into 1 by 2 plus 1 by 4 plus 1 by 2. This is 2 by 5 into x. That's all. And this is nothing but 3 by 4. Okay, 3 by 4. 2 into 3 by 4 plus 1 by 2. 2 by 5 into x. So it gets cancelled. Okay, so this will be how much? Okay, correct. This will be how much? This will be 4 by 2. 4 by 2, 2. This will be 2 by 5 into x. 2 gets cancelled. So what is x? X will be 5. X will be 5, like that. Okay, good. Next, and this question. Okay, we are just rotating the rod. When you rotate the rod, what happens? We can apply law of conservation of energy. Rotational kinetic energy will be equal to potential energy. Come on. So a rod of length 50 centimeters is fixed at one end. It is raised such that it is making an angle of 30 degrees. 30 you can say, theta degrees also you can say. Then the angular speed when it passes through the horizontal, correct? Horizontal. You can say down or anything. Okay. It is. So I want to know I want to know what the angular. It is one the same only. I want to know what the angular speed when just passes through that. E questions again take the center of gravity. Kinetic energy is loss in potential energy is equal to gain in kinetic energy, but we have to use rotational. Half into I into omega square. But what is I stands for? Where I is equal to moment of inertia of the rod at the edge. It will be m L square by 3. It is m L square by 3 because we are rotating the rod at the edge. So this is the change in the kinetic energy. Now we want potential energy. Potential energy point of view, we will take the weight of the rod mg, and the potential energy is displaced from this point to this point because they said horizontal. Okay, so I want this distance mgh. I want this distance, but they have not given that distance, so they gave only length of the rod. So to complete this triangle, I have to take half of the length of the rod. Okay, so when you apply sin theta will go h value. Sin theta is nothing but h by L by 2. So h is equal to L by 2 sin theta. So like that we got h value, and the force is mg. Therefore potential energy is equal to vertical force into vertical displacement of the center of gravity. Vertical displacement of the center of gravity will be L by 2 g sin theta, like that. And if you want, you can put theta as 30 degrees also. We can do the work. Okay, yeah. So now what I have to do? I have to apply that I value. So 1 by 2 into m L square by 3, because the rod is rotated at the edge, into omega square. Of course, sorry, I different m's not required, same m only. That's not a big issue. So m into g into L by 2 into sin 30 1 by 2, like that. Omega ana vendadu. 2 gets cancelled, L gets cancelled, mm gets cancelled. That's all. Now omega square is equal to, we have to do cross. ഇവിടെ 3 ഉണ്ട്, അവിടെ 2 ഉണ്ട്, അവിടെ g ഉണ്ട്, ഇവിടെ L നിൽക്കുന്നുണ്ട്. Okay, L is there. That's all. Yeah, we have to do calculation. So omega is equal to root of 3 into 10 by 2 into L. L is nothing but 50 centimeters. I will take it as 1 by 2. Okay, 50 centimeters means 0.5 meter. That. Now this 2, yeah, very good, gets cancelled. Answer is root 30. Answer is root 30, like that. So in this context, what we have to do? We have to apply law of conservation of energy. So change in rotational kinetic energy is equal to change in potential energy. So when you are taking I, you should be very careful. You should not take ml square by 12. You have to take ml square by 3. And when you are applying potential energy, mg into vertical displacement, so we have to convert L into H. Yeah, this question simple only. Moment of inertia is given. How much? 1.5. Moment of inertia is given. Initially it is at rest. So omega naught is equal to 0. Okay, we are doing work in order to produce a rotational kinetic energy. So they gave rotational kinetic energy. So rotation 1, 2, 0, 0 that. Upper rotation kinetic omega get. Okay. And the angular acceleration also they gave. Angular acceleration will be 20 radians per second. And they want to know what the duration of the time. To acquire an angular acceleration of 20, what the duration of time. Okay. We'll start with rotation kinetic energy. Of I omega square is nothing but 1200. They gave I can find out omega. That is omega. Omega means omega t. Omega means omega t. So omega square is equal to 2 into 1200 by I. I is equal to 1.5. I will write it as 3 by 2. Okay, so now everything will get cancelled. See, we are getting here 400. Okay, so we are getting 16. So it will be 40. Your omega will be 40 radians per second. Now how to find out t? We know that omega t is equal to omega naught plus alpha t. But omega naught is 0 because initially it is at rest. Okay, so t is equal to omega by alpha. How much we got it as omega? 40. How much alpha they have given? 20. 40 by 20. What is 40 by 20? 2. 2 seconds will be answer. Simple equation of motion question. Next. The next question will be, read the question. A metallic coin means we can take it as disc. Okay. And this is in grams, be careful. And this is in centimeter, be careful. Is fixed to the disc. It is like this. See, this is the disc. Think that if this is the disc, it is rotated about this. That tangent of to get moment of inertia. What you have to do? Have idea about diameter. For that apply parallel axis theorem. So this is moment of inertia of the disc about the tangent. Okay. What the original value? mr square. mr square by 2. About diameter how much? mr square by 4. For that add 1. Because parallel axis theorem, add 1. mr square by 4 plus 1. How much? 5 by 4 mr square. So that will be the moment of inertia of the coin we have to take in this case. Because the coin is rotating about an axis. The axis is tangential to the disc like that. So the I should be taken like this. The constant torque that will be make the system. So they want to know what the torque. Torque gitta vendi I kandudiya. That I formula is ready. Okay, so that system rotates about, so that it will go for 25 revolutions in 5 seconds. What is 25 revolutions? Frequency. And so they gave frequency. From that we can find out omega. And I know omega. I know t. So I can find out alpha. By that time I know I know alpha. I can apply I alpha. I will get torque like that. So one by one we'll do. So first it is the moment of inertia of the disc about the tangent. So we have to apply 5 by 4 mr square. Calculation if you want you can do afterwards also. 5 by 4 into mass is 5 grams. 5 grams means divided 1000. And radius is 1 centimeter. 1 centimeter. Tell me what you have to do. 1 centimeter square. So it will be 1 into 10 raised to minus 2, 10 raised to minus 4. So all together it will be 25 by 4 into, and this is going up 10 raised to 7. That is the moment of inertia. And next I have to make ready with alpha. Okay. So initially it is at rest. Again. Initially it is at rest. So f of 0 will be 0. Therefore omega naught will be 0. After that they gave f of t. What is f of t? It is 25 rotations per second. So it will be 25 rotations per second. Okay. With that I can go for omega t. What is omega t? 2 pi f t. 2 pi f t. That is 2 into pi into 25. So how much will get? 50 radians per second I am getting. And they give time also. So we can find out alpha. Omega t is equal to omega naught plus alpha t. Therefore alpha will be omega t by t. Omega t is 50 pi by t. What is t? 5. So it will be 10 pi. So your alpha will be 10 pi radians per second. So now think, we got I, we got alpha. They are asking tau. They are asking tau, the constant torque required. Tau is equal to I alpha. Tau is equal to I alpha. By the time I is ready, 25 by 4 into 10 raised to minus 7. And we calculate alpha also, 10 into pi. Now do rough calculation. Okay, you can do rough calculation. So yeah, okay, pi vanda. So it is 25 into 10 into pi, approximately I am taking 3 by 4 into 10 raised to minus 7. And this will be around how much? 0, 15, 2, this will be 13, okay, 30 means 75 by 4, approximately, I am doing approximately. So yeah, approximately only I can get it correct, approximately. So this will be around 1 point, balance will be 35, 1.8. So 1.8, 1.9 we are getting. So it cannot be 1.6. So it will be approximately 2 into, and the balance will be, there it is, what? It is in 100, na? So the decimal comes to be this. I think this will be the answer. Correct. Yeah, correct. She is correct. Okay. And here 25, 2 into pi. 25, 50 pi, 50 by 10 pi, 10 pi. But only thing is you have to do the calculation a little bit is enough. Okay. Because there's a lot of gap between this. And this goes on finally. A force F, they have given force F acts at a point. So suppose if you have a rigid body like this, okay, force is acting at this point. Force is acting in this way, like that. So its point position vector is given. This is OP bar. OP bar is given. Okay. Then the magnitude of torque about the point. Here. Okay, here, about, and then generally O I will take it as A for about. So now the whole system is rotating about A. For that, O is also having position vector. OA bar, like that. Then how do you find out the, we want torque. Torque is in the form of root x. Will be root x of that. So then what is x? Okay, we'll see. Yeah. So first, we know that torque is nothing but R bar cross F bar. So we have to do determined model. I bar, J bar, K bar, and we have to find out R1, R2, R2. Then we'll put F1, Fx like that. Okay. So first we have to find out position vector. So how do you find out the position vector? Which is the position vector? R bar is equal to AP bar. AP bar is equal to OP bar minus OA bar. So I had to subtract this from that. So then it will be 4I cap plus 3J cap minus K cap minus of I cap plus 2J cap plus k cap. So when you do the subtraction, it will be 3i cap and plus j cap minus 2 k cap. This can be considered as the position vector. Now we have to find out tau. Tau is equal to determinant model I, j, k. After that we have to write the components of r bar only. Now the components of r bar will be 3, 1, minus 2, and then we have to write components of force 1, 2, 3. And now we have to do the determinant. So I will get I bar. Of course you know the method. Okay. Yeah, I will get k bar. That is I bar will be these two. 3 plus 4. So it is 7. J bar will be 9 plus 2. 11. Minus it 11. And this will be 6 minus 1. 5. So the torque will be 7i cap 9 minus 2. No, here. No, this is 9 plus 2, correct. 11i j cap plus 5 k cap. But they are asking for the magnitude. Okay. So the magnitude will be root of, this is 49, this is 121, and this is 25. This will come out as, let me see how much it will be. 10, 15, 5, 9. Okay, good, got it. Yeah, but this is root of 195, but they put it in the form of they should be in, they are giving tau as root x. So they want in the form of root x. So we got tau as root of 195. Root of 195 is equal to root x. Therefore the value of x will be 195. This is the trend now in IIT classes. Okay, they will put some form. For that form only we have to find out the value of x. And this type of questions generally they will ask in the numerical integer questions. Okay, so like that we have to do 195. Okay students, I think you got a revision of all the questions, that is rotation dynamics and work power energy. Again, if you have any doubt, please go through that. Best of luck.